case, let's assume that we have a keypad. And this keypad has R1, R2, R3 and R4 and C1, C2, C3 and C4, and now it is connected with a microcontroller. Okay, and then within the microcontroller now you have different LCDs. You can use, okay, now okay, how many keys are there?
4 plus 4, 16.
16 keys are there. How many bits can be used to represent these 4 keys?
4.
4 bits. Okay, now what's our objective? Our objective is to connect this keypad. So now we have a keypad. Okay.
Yes, sir.
And with the microcontroller, and now we have to send the corresponding code. So now this is VCC. So this is active high logic or active low logic?
Active high.
Active low logic, because this is VDD. So it's 0, LED will be on. Okay. So if the code is 0, 0, 0, 0, so it means
So,
all of them are
on.
on. Okay. Now if you look at this keypad, so there are 4 rows and 4 columns. So N1, N2, N3 and N4 are the columns. I call it C1, C2, C3 and C4.
It is rows. Ye rows is.
No, N1, N2, N3 and N4. These are columns.
Acha sir. N1. Yes sir.
N1. And M1, M2, N3 and N4 are the
Rows.
Okay. So now if we press this switch 0, this is 0. If you press this switch 0, it means that M1 and N1 are connected.
N1 and M1. Intersection actually they
Because
call
it is the intersection of M1 and N1. Okay? So, and if this M3, if we press this switch, so it means which switch is connected? So this is M3. M3 is connected with N4. Okay? Agreed?
Yes sir.
Okay, so now we can have an intersection of this, like it will be very easy from here. So this is C1, C2, C3 and C4, R1, R2, R3 and
R4.
R4. So this code is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. Okay, so if we want to write the code for this keypad and this controller, so naturally we first need to drive the rows and scan the columns, or scan the rows or drive the columns. So now let's assume that this R1 is connected with P1.0, P1.1, P1.2, P1.3, P1.4, P1.5, P1.6 and P1.7. So these are the input ports or output port. P1 is the input port or output port?
P1 is input port.
No, depends on. I will explain it why. Okay, so now let's assume this is P2.0, P2.1, P2.2, P2.3. So okay, now if you look at here, so can we write it like this? R1 equal P1.0, am I right?
Yes sir.
R2
Equal
equal
P1.1.
P2.0 and so forth so on. So then you can be C1, C2, C3 and C4. You can have the
Equal command.
P1.4 and then you have P2.0. No. Okay, now you have LCD not sensor. This is LED. L1. L1 equal what?
P2.0.
P2.0, L2, L3 and L4. So now this is the configuration. In order to make our program more ready. Okay, now we start with the main program. Whenever you want to connect this keypad with the microcontroller, so first you have to drive the rows, then scan the columns. Drive the rows and scan the columns. This is called as raster scan, some kind of scan mechanism. But I will explain this with an example. So now if we are driving the rows, so actually
ये हम उल्टा भी तो कर सकते हैं कि ड्राइविंग द कॉलम एंड
scan
स्कैनिंग
the
द
rows. Okay, so now in this case we assume that we are driving the rows. So the code that we are sending is 1000. So we are driving the rows. So when we are driving the rows, so actually what will be the code? Set R1 clear, R2 clear, R3 clear, R4. So now we are driving the rows. Now we need to scan the columns. Okay, now we want to scan the columns. So when key 0 will be pressed?
जब C1 पे हाई
When C1 will be 1. So actually check, we can write it like this, check 0. Check 0. So check 0, so it means move. Now we are scanning
स्कैनिंग C1
scanning C1. So move C1. We can move. Okay. Now I will call it set row 1, row 2, row 3, row 4. Because I don't want to confuse row with the registers.
नहीं सर, हम इस तरह नहीं करेंगे कि सर C1 जो है P1.4 के साथ कनेक्ट है, तो हम P1.4 को देखेंगे, अगर इस पे हाई आ रहा है
Yes.
तो मूव नहीं करेंगे सर हम
क्या कह रहे हैं?
हम कंपेयर करेंगे P1.4 को 1 के साथ.
But we can also first we need to move this value into some register. So move R0 in any registers C1.
ठीक है सर.
And then compare
C1
R0 with, okay, now we are saying 1.
1 यस सर.
Branch if it is equal,
तो 0 डिस्प्ले होगा.
display 0. So display 0 is here. Now if you want to display 0, what is the code for 0?
ASCII कोड.
No, the code for 0. 0 0 0 0.
यस सर, सारे 0 0 दो.
सारे 0 0 0 होंगे.
जी,
So
sir.
all LEDs will be off.
यस सर,
All LEDs will be off.
विल बी ऑफ.
Okay, now in order to make your life more easy, we can also connect it to the 7-segment display. This is your, which one is your A? Actually A start from here. A, B, C, D, E, F and G. So can we write it like this? That A equal P 2.0, B equal P 2.1. This is A, B, C, D, E, F and
जी.
G. So display 0. So to display 0, what value did? Okay, so it is connected with P2. It is connected with P2. So we can move. Can we write it like this? Move P2
P21
hash. Hash is for immediate value.
यस सर.
Impercent is for
Binary.
binary. So to display 0, so actually this should be 0, 0, 0, 0, 0, 0 and
1
1. Okay, now it starts from, so actually the code will be 0 0 0 0 0 0 0 1 2 3 4 5 6. Okay, now it's display, so then you call it, then you say jump
Binary.
delay. You go to the delay function.
यस सर.
In delay function, you say move R3 hash from larger value.
200 यस सर. यस सर.
Decrement
R3
R3 compare
R3 with 0
R3 with 0, branch not equal, delay and then return. But branch not equal delay
ब्रांच नॉट इक्वल डिले नहीं, इधर कंपेयर
and then jump main. You're going to go to the main. Okay.
सर. ये ब्रांच नॉट इक्वल के बाद जब ये डिले पे जाएगा तो फिर वही वैल्यू मूव होगी.
Jump delay. First, if you will move this value, then you give a delay, so that if some user will press another key, so it will wait for some time. jump delay, the delay function will be called, it will be moved to the memory. Okay, now
सर ये 0000 क्यों किया आपने वो?
ये ज़ीरो का कोड है ना, ज़ीरो के लिए।
and the LCD is on and active low logic. A will be 0, B will be 0, C 0, D 0, E 0, F 0 and G is 1. Okay? Okay. Now
सर एक क्वेश्चन है, ये डिले ठीक नहीं है सर मेरे हिसाब से।
क्यों ठीक नहीं है?
सर R3 में हम ये बड़ी वैल्यू मूव कर रहे हैं सर, तो जब एक दफ़ा डिक्रीमेंट होगा तो ये एक डिक्रीमेंट होके कंपेयर R3, तो जब ये नॉट इक्वल होगा तो फिर ये डिले पे नहीं जाना चाहिए, ये थोड़ा नीचे होना चाहिए। यस सर।
Yes.
इधर सर कोई और लेवल दें, क्योंकि जंप डिले। यस सर, यस सर, वेट।
Yes, you are right. You are right because you are initializing to this, then you are decrementing R3, compare R3 with 0. Jump delay, compare R0 with 1. Now we have moved C1. Okay, then move R0. Okay, now we want to scan C2. Move R0, C2.
यस सर।
Compare R0 with 1. If it is equal, it will display on what? Where?
डिस्प्ले 1।
Display 1. What will the code for display 1? Move
P2
P2 hash ampersand. Okay, now we want to, the value of A will be 1.
ज़ीरो नहीं, 1 इस तरह नहीं होगा, सिर्फ 2 ऑन नहीं होंगे, F और E ऑन नहीं होंगे सर।
It will be 0 and 0, all the remaining will be 1. A will be 1. We are starting from A.
हाँ ठीक है सर।
A will be 1, B will be 0, C will be 0 and all the remaining are 1.
यस सर।
So this is your A, B and C. Because we are working at active low logic, not active high logic.
यस सर।
An active low logic, okay? Similarly, you can further move on.
ठीक है सर।
Okay, now in the next iteration, R0 to C2, R01, then move R0, then C3, then C4. In the next iteration, we will then clear row 0,
ठीक है सर।
1, 0, set row 1, clear row 2, clear
रो 3, रो 4।
row 3, and then we move to compare to, then we will compare with C1, then we will jump on 4, 5, 6 and 7, and when it reaches the last step, it will again move to the
यस सर।
main. So actually this is the code that how do we interface the keypad with the microcontroller. So there are two mechanisms.
प्रोग्राम कंट्रोल इंटरप्ट है ये सर।
This is a program control IO, not program controlled interrupt. Program controlled IO. It is not an interrupt based mechanism.
इंटरप्ट यस सर।
It is not an interrupt
Program
based
controlled
mechanism. It is a program controlled IO in which all the pins are. So it may, if you want to have a keypad controller and we want to control this keypad with a simple microcontroller, so there are two mechanisms. First we drive the rows and scan the
columns.
or we drive the columns and scan the
Rows.
rows. And actually this is the key code. So this is the key code. So in this case, what will be the code? So if 0 is pressed, so the code will be 0 0 0 0.
यस सर।
1 is pressed, the code will be 0 0 0 1. When 2 is pressed, 0 0
0 1 0।
So actually you can have a keypad. In this case, we have now a keypad, and keypad is then connected with what?
7 segment display।
7 segment display. In this case, this example, it will take the value and the key code. So what key code will be generated in this case? For the first case, display 0.
सारे
No,
0
the code will be 0 0 0 0. Display 1 will be 0 0 0 1. Display 2 में
0 0 1
0
0।
0 0 1 0. So far.
ठीक है सर।
So this is the outline of this chapter. We will study interfacing basics, microprocessor interfacing, IO addressing, interrupt, DMA, arbitration, hierarchical buses, protocols. So if you look at the embedded system functionality aspects, so if you look at the microprocessor performs three tasks. It performs data transfer, data transformation, and control instruction. Okay, and it is implemented using microprocessor. If you look at the storage retains some data. So there is the different type of storage device we are studying, hard disk and the memory. So it retains some data and it is implemented using memory. And we also need some communication, because in communication we need to transfer the data between the memory into the microprocessor, and it is also we implement it using buses. We also call it interfaces. And if you look at the buses, so bus can be divided into different components: address bus, data bus, and control bus. Okay. So this is the simple structure of an embedded system. So if you look at the buses, so buses are implemented using wires. Wires can be either unidirectional or bidirectional. So one line may represent a multiple single bit or multiple bit. So this is a single bit, read write bar is a single bit. Enable is also single bit. Address is multi-bit and data lines is multi-bit. Address is single directional or multi-directional?
Single direction.
Data bus is
Multi-directional.
Okay, so this is a single bit or multi-bit signal? Multi-bit. Address lines are multi-bit because it's 12 bits. Okay? So, but bus is a set of wires with a single punch, address bus and a data bus. And we also have some control bus. What are the example of control bus? Read write bar or address stove.
Yes, sir.
We also studied that address stove is a signal that is generated by the, and what is the associated protocol? So there is also some protocol for communication. If you remember the protocol for the serial bus, so the protocol starts with a start bit and a stop bit, and then you also have some parity bit in between. So this is the protocol of transfer. And in the protocol you also determine the data rate. What's the data rate? With what data rate the data can be transferred from one device to the another device. So actually, if you look at this kind of a bus structure, we have a master and we have a slave. Okay. So if you look at a microprocessor-based system, who is the master? Microprocessor. And who is slave?
Memory.
Memory slave. Because memory is a passive device. Okay. So if you look at the ports, so the ports is actually the pins on the microprocessor. They are also called as referred to as pins. So these are the pins of the IC package, and these are typically metal pads. They are implemented with metal pads. Okay. So it's a single set of wire or multiple set of wires like this. In the address bus, this is implemented with 12 bits pins, and the data lines is implemented with 8 bits in this particular example. And enable is with 1 bit, and read write bar is 1 bit. So now this is the timing diagram. So if you look at the buses and if you see some timing diagram, so it is the most common method for describing a communication protocol. And if you look at the time, so time proceeds on the right, on x-axis. Okay. So the control signal can be either low or high. Okay. So it may be active high or active low. So if we say that this signal is E, this is active high, this is low, now it is high. Now if this E bar, so this is deactive and now it's active. But if it's E bar, then
it is active and deactive.
We also got as deasserted and asserted. It is called as
Asserted and
asserted and deasserted. Now if you look at the, okay, now this is for 1 bit signal. A 1 bit signal can be active high or active low. Now if we look at this LCD in the 7 segment display, in the 7 segment we assume that it is active low. For active high, it will be on when the value is 1. Okay. For active high, when it is 1, it will be 1. High.
Yes, sir.
And it will be like the LED will be blown.
Yes, sir.
Okay, now, but if it's a multi-bit signal, it's a multi-bit signal. Let's assume if it's a data bus, it's a multi-bit signal, it's not one. So actually, it means that it's inactive, now it is active. If it is an 8-bit data, so if we say 1 0 0 1 0 0 1 0 1 2 3 4 5 6 7 8, so it's an 8-bit data. So if we represent it in hexadecimal, so it is actually 9
into.
It is actually 9. So actually it is inactive. Now it is
Active.
active. So if you look at the data signal, so now in this case it is Inactive. Now in this case it is
active.
active. Oh, so the data signal is valid or invalid. So during this case it is valid signal or invalid signal during this time. Valid and invalid. Okay. The protocol may also have sub-protocols. If we call it as a bus cycle, if we want to make a transaction between a master and a slave, so this is called as a transaction. So the transaction can be a read transaction or a
Write
write.
transaction.
So the protocol may have sub-protocols. So it means we can further divide it into a read bus cycle or a write bus cycle. And each may contain several clock cycles. Now if you want to read some data, so we may get the data in a single clock cycle or we may get the data in multiple clock cycle depending on the latency of the memory device. So the latency of the memory device may have fixed latency or the latency may either be variable. Okay? Now if you look at the read protocol, so actually then this is a read protocol. Now there is a bar on RD. So read write bar is 0, it means it's a read operation.
Read operation.
Enable is 0, when enable is 1. So if enable is 1, it means now microprocessor wants to access some data. There was a signal that was inserted by the microprocessor. What is the name of that signal? If you want address strobe. If you remember. So if enable is 0, it means it's not, microprocessor has provided an address. But it has not yet latched the data. So the data is provided here. So it means the latency when the enable is 1 till the data becomes available. So this latency is called as read latency. Read latency. So microprocessor provides an address. The enable becomes 1. The time duration between when the enable is high from the microprocessor till the time becomes available. This delay is called as the read delay. The read delay. During this time the data is invalid. Why it is invalid? Because it takes some time for the memory to get the data from the memory and put it on the bus. So if you look at the memory, so actually the memory is, there are a lot of, in memory there are multiple banks and now these are the pins of the memory. So it takes some time to get the data from the memory bank and to put it on the bus. Okay, so actually when the microprocessor gives enable is 1, so microprocessor makes a request, I want to read some data from here. And now the data is available here at this point. So this latency is called as read latency. In this write protocol, when the enable is 1, okay, in the write case, what will be the direction of the data? From the microprocessor to the memory.
Yes, sir.
So in this case, microprocessor will both provide the address
And the data.
It will also provide the data. So when the enable is 1 until the data is written into the actual memory locations. But if you look at the memory contains many addressable locations. If you remember from the memory, so if we say it is 2A cross M, how many addressable locations we have?
2 to the power n.
A addressable location. So when we have to respond A addressable location, so we have to write on one of these addressable locations. So when we given a particular address, the value will be written to that memory location, and the data will be written after some delay. This delay is called as the write delay. Now if you look at the basic protocol concepts, so now we have some actors. We have a master initiate the transaction, and the slave that respond to the transaction. Who is the master? Microprocessor is the master. Who is the slave? Memory is your slave. What is the direction? So the direction is the sender or the receiver. This direction is typically determined by the control signal. And in the microprocessor case, it's a read-write bar signal. So when read-write bar is 1 or 0 depending upon the polarity. So actually if it is 0, maybe it's a read operation. If it's 1, it's a write. Depending upon the signals, whether it has a bar on R or bar on W. Okay, so address is special kind of data. It specifies a location in memory, a peripheral or a register within a peripheral. Actually, so if you look at the memory, so there is a logical map. You need an address, you need the data. So this address is provided on the address lines and data is provided on the data lines. Okay, now we also have different type of scenarios. We can have a time multiplexing. Now there are two scenarios. One is scenario number 1. Now you have a master and now you have a slave. So you need, if you look at the data bus, what is the data bus size here? 8 bits. Let's assume if the data bus size is 8 bits, what is the advantage? You need less number of pins. But the data in which you are interested is 16 bits. How many clock cycles are required to access that? 2 clock cycles. So you need to send 2 requests. In the first request, you latch the most significant byte of your data, and in the second clock cycles,
least
you
significant
see
byte.
the least significant. So it requires two transactions. One transaction to get the
Upper byte.
upper byte and one transaction to
Lower
so
byte.
actually this time multiplexing is used when the size of the data you want to read is greater than the size of the bus.
Bus.
If the
Data.
bus size is equal to the data size, you need one clock cycle. But in this case, you need two, not one clock cycle, it can be multiple cycles. You need one transactions. To get the data, how many transactions you need?
Two.
Two transactions. One transaction to get the highest bytes, other transaction to get the
Lowest bytes.
Now, if it's also in another scenario, we have an address and a data multiplexing. We have an address and a data multiplexing. And in this address and data multiplexing, it means that now in this case, the same lines are used for the address and the same lines are used for the data.
Data.
First, you will transfer the address. First, you will transfer the address on the same lines, and in the second cycle, you will receive the data. Okay. So now, if we have this microprocessor, and now you have memory. So these lines, these are bidirectional. It can be used both for the address and the data. So now if we have memory, and now if this address is 1024 and the value is 5639. So first you will provide which address?
The most significant.
No, 1024. Not more significant. This is
Pura
line number
identical.
2.
So,
The same line is shared between the
Data bus.
address and the data. In the first cycle, you transfer the address.
yes.
You transfer the address 1024, and in the second cycle, the
Data is fetched.
56.
ये हार्डवेयर आर्किटेक्चर है सर
क्या?
वन न्यूमैन
No. Architecture is not architecture. Von Neumann, in all cases, it is a von Neumann architecture. Von Neumann architecture is a stored program concepts. It stores the data in memory. It's actually different implementation of the memories.
ठीक है
In different implementation of the memory. In this case, the size of the bus is smaller than the size of the data. In this case, we are sharing the same lines for the. Otherwise, okay. Now, if let's assume if this is 60, we have two architectures. 16 lines for the address and 16 lines for the data, and this is your memory. How many pins are required? 32 pins.
Yes,
In this architecture, how many pins are required?
16
16 plus 1. Why? You said what is when you are transferring the address or data. So when it's 0, it means in this cycle you are transferring the, and in the second cycle you are transferring the
data
data. Okay, so when address bar data is 0, it means you are transferring the address. When it's 1, now you are transferring the data. So it is actually time multiplexing. It is the sharing of resources. It is the sharing of resources. Let's assume if you go to the library and there is a book available. So these books are shared between multiple students. Similarly, it is the sharing of resources, the sharing of the buses between the address lines and the data line. Now there are two scenarios. If we have dedicated lines, what is the advantage? We get the data in one transaction, one cycle. But what's the disadvantage?
more pins
We need more pins. What is the advantage in this case?
less pins
We require less number of pins, but what's the disadvantage?
टाइम ज़्यादा लेगा
Because of the multiplexing.
Single load and line.
Okay, so you need two multiple transactions. So these are two different scenarios or two different architectures. Now if you look at the basic protocol concept or the control methods, there are two types of protocols. One is the stroke protocol and one is the handshake protocol. In a stroke protocol is used in the scenario when the memory has fixed latency. You always know that you will get the data after some time. So it means, so there are 4 points, point number 1, point number 2, point 3 and point 4. In point number 1, master asset request to receive the data to the servant. It assigns the request. So the request line is be from 0 to 1. Servant puts the data. When it puts the request, servant will put the data on the data bus. Servant puts the data on the bus within time t access. So this is t access. The time between the request is made until the time becomes available. The difference between these two times is called as
access time
Read it.
access time or read latency or access time. We call it access time. Okay. Master received the data at point number 3. Master latch this data and it puts this request to low. Now the communication is done. Now I will explain this with an example. Now let's assume if somebody wants a request from me, he will raise this hand. This is point number 1. Okay, then I will respond to hem. I will respond to hem. So actually, this difference time is called as excess time. After, at point number 3, he will put his hand down. It's time number 3. And the servant is ready for the next request, then I will be able to service the request from the others. This protocol is called as a stroke protocol. This protocol is called as stroke protocol. Now, there is also a handshaking protocol. In handshaking protocol, master assert request to receive the data, servant puts the data on the bus and assert acknowledge. It also signal acknowledge. That okay, I acknowledge this signal, then master receive the data and reassert request and servant ready for the data. This type of mechanism is called as handshaking protocol. To implement the first protocol, how many control signals are used? 1.
1.
But that is request. In this case, how many control signals are used?
2.
Request and
Acknowledge.
there are 2 control signals. The data is same for both. Now, we also have another kind of protocol. We also have like 2 scenarios in which we call this a strobe and handshake compromise. So, if we have a master and a slave, so there are two signals, control signal. One is request and another is wait. Okay. So, master assert request to receive the data. Servant puts the